Okay, so this is the first part of the first lecture. This is what you should read from the book. These are parts of chapter 1, basically. Now, this is the agenda. We will go through the different points. Notice that some of them are marked as self-reading, so that is for you to read on your own. Let's start with what is an operating system. So there are different layers that you can think of when you think about a system or, say, a computer together with the users that are working with it. Okay, so you have the hardware, you have the operating system, you have the set of applications that are being run on the operating system, and then you have the different users. Okay, as I said before, the operating system stays in between the hardware and the users. Here you see that it's actually between the hardware and the different applications, processes, programs. We will see what is the right term for them that the users are interested in. Now, what defines an operating system? It's, of course, in part related to the hardware that is being used below the operating system. If you use an iPad or if you use a smart washing machine, you might need to have modules in your operating system that allow to use fingers to give input to the hardware. On the other hand, on your desktop, you might have just mouse and keyboard, and you don't need to have a touch screen. So your operating system does not need to have a module for that. So the first point here to take into account is that we will see this many times. Hardware and operating system are tightly connected. And again, this you already saw last time. The operating system, as we said, sits in between the hardware and the applications. On one end, to sort of provide a easier or more beautiful interface, if you want, when you want to communicate with the hardware for input and output, to shield the user from the hardware, but at the same time, the hardware from the user, or if you want, a certain user from another user when these two or more users are using the same hardware. But it also acts as a resource manager for the different computational units you have in your computer, so the CPU, the memory, and the other devices. Now, what is the normal life cycle of a computer? So, put it in another way, how does the operating system manage devices and users? This is what I showed you last time, and we saw that I said this, that you have a very fast brain in your machine, but it's pretty stupid. It just takes the next instruction and runs it, okay? But you know that in practice you have a lot of devices. They are different, from printers to monitors to keyboards to disks and so on. So the question is, how do you use such a brain to control all these things? Well, the answer to that is events or interrupts, okay, which are the entities, the things that are marking the cycles of the operating system. So the figure I show you, it's sort of lying, meaning that it's not giving you the complete picture. This one is the correct one. So what the brain does, the CPU, is to take the next instruction and run it. But it can only, but it can also decide after running an instruction whether to take the next instruction and run it, or to check if something has happened, okay, if there was an interrupt, and based on that, go back fetching the next instruction, but in this case, a different next instruction. We will discuss several times what this means, so you don't have to worry too much right now. But so that you start getting into the mood about these things, you have to assume that the operating system is doing some work. It's running Spotify, there is an interrupt, something happens, okay? It might be the disk that tells the operating system that a certain file has been copied from the main memory to the disk. This is an interrupt. The CPU, once it's done with the current instruction that belongs to Spotify, will check what is happening. And depending on the case, for example, if the disk has completed transferring something from memory, we'll decide what is the next instruction that will be executed, okay? Oh, in this example, it's a keystroke, need to print a character on the screen. Okay, then it takes the important instruction to do that, the relevant instruction, and it does that. Once it's finished, if there is nothing more to do, then it goes back to running Spotify. There is another interrupt. The operating system checks what is happening now. Okay, now it's the disk that has done something. Okay, then I will tell the disk to copy something else. I will get another interrupt and so on. Okay, I mentioned before that you have the feeling that many things are being run at the same time, while in practice, it's only one thing that is being run. Sometimes, okay, this is not necessarily true, we will see this. The thing is that, as I said, since the brain is extremely fast, you have the feeling that they're running at the same time. What is happening is that the operating system is continuously switching and deciding what is the next instruction I should run based on the interrupts it gets.